Hello everyone. As we said that earlier, we have started the structure of the entire navigation message, and a frame is of 1500 bits long and it takes 30 seconds to transmit. And these 1500 frames, that bits are divided into 5 frames. That if you see that here we have 1500 bits are divided into 5 subframes, and each subframes of 300 bits, and it has the duration of 6 seconds. Each subframe is in turn divided into 10 words. This one we can see here. This one is about complete subframe and have 10 words. And these 10 words each containing 30 bits. So that total of 30 bits here. Each subframe begins with a telemetry word and a handover word. That is TLM word and HOW handover word. TLM, telemetry word and handover word. And a complete navigation message, it consists of 25 frames, or we can say that pages. The structure, if you see that it has complete message, we say that is about 25 pages per frame. Now a subframes contains the information. If you see that the frame is divided into 5 frames, 5 subframes, and each subframe transmitting a different information. Consider here subframe 1. It contains the time values of the transmitting satellite, and that includes the parameter for correcting signal transit delay and a on-board clock time. And again, it consists of information of satellite health and an estimate of the position accuracy of the satellite. Subframe 1 also transmits 10-bit weak number, and that is a value from 1023 bits, that is 0 to 1023 bits, can be represented, earlier we say, that is by the 10 bits. So we can consider that every bit restart with a 0, and the GPS time is to be considered every week there, and it is to be restart at 0, and that is called as a week rollover. Next is subframe 2 and 3 contains a ephemeris data of transmitting satellite, and this data provides extremely accurate information on the satellite orbit. Then subframe 4 contains the almanac data on satellite number 25, if we can have a total number of satellites, if you consider that. So in that case, that is data from the satellite only, and that data consists of a difference between the GPS and a time, and that information regarding any measurement error caused by the ionospheric layer. Then subframe 5 contains almanac data on a satellite that is used here, because 24 satellites are there, so from 1 to 24 satellites information, and that satellite can transmit data from one satellite only, and all 25 pages are transmitted together with information on the health of a satellite of all these 1 to 24 here. and this express satellite and standby satellite information present here, and this one the information of a satellite is in use in the given orbit. Now the TLM and a handover word, and if you see here the first word of every single frame, this one you have first word of your frame, and that consists of a TLM, that is telemetry word, and that contains a preamble sequence 8 bits in length, and that is used for the synchronization purpose, and followed by a 16 reserved bits for authorized user, and then a 6 bits of the telemetry words are parity bits, that is for all the words. Then the handover word that immediately follows by this TLM in each frame. That handover word is 17 bits in length, that is, if you see that from the given particular data, that is range of this value, that is about the 17 bits, and that contains the structure, that is the start time for the next subframe, and that is transmitted at the time of the week, that is TOW. And this time of the week count begins with the value 0 at the beginning of the GPS week, because we can say that rollover after every week there, so that it contains the week information, and that consists here, we start here from the Saturday to the Sunday there, transition period, and that it increase by a value of 1 every 6 seconds. So you can consider that is a bit transmitted in the every second there, and then you can say that the count for the given week runs from 0 to, for the given 17 bits, that is, you can have the range values 131071, that is represent that particular bit, and for the week information we can say that value is required, that count for this particular bit there. It starts from the 0 and end it to the return it to the, that is from the highest to the return it to the 0. Then the marker is used into the data stream every 6 seconds, and then a handover word transmitted. To provide the synchronization information, a P code bit is used, and that bit is used in the handover word to identify the subframes. Now the subdivision of that 25 pages, your complete navigation message required a 25 pages, and a 12.5 minutes required for this particular 12 pages. And this page, or you can say that frame, is divided into 5 subframes, and in case of a subframe 1 to 3, the information content is the same for all 25 pages, and that is meaning of that the receiver has the complete clock values and ephemeris data from the transmitting satellite every 30 seconds. So this one, we have data transmission there, and the difference is in the case of what subframe 4 and 5, and how they transmitted the information in the organized manner. If you consider in subframe 4, that pages 2, 3, 4, 5, 7, 8, 9 and 10 relay the almanac data on the satellite numbers that is standby there, and in each case the almanac data, if we consider there a total number of satellites, according to that data required, and that almanac data for one satellite only is transferred per page. So that is about your almanac data and that pages information. And it's subframe 5, that is almanac data of a satellite there, that is used for the transmission of information there. Now if you compare that a ephemeris data and almanac data, so that both the data, ephemeris and almanac data, that satellite orbits and their relevant coordinates of a satellite can be obtained through this data there at any defined point. And the difference of this particular data is nothing but depending upon that number of bits transmitted. And if you consider that almanac data and ephemeris data, it consists of that or the satellite position. And suppose if you see a semi-major axis of a orbital ellipse, in that case ephemeris required, that is 32 bits required for the ephemeris, and for the almanac 16 bits required. Then eccentricity of orbital ellipse, to 32 bits for ephemeris and 16 bits of almanac data. That is for your message, GPS message, how you transmit the information there. So we can have the beta bit and the data that is transmitted. So we can say that for the given message, GPS message, from this we say that it transmits 37500 bits, and that occupies a 50 bits per second within a 12.5 minutes. Then we can summarize that this message contains a system clock and a correction data, that is highly accurate orbital data, and the orbital position of all the satellites. We can have almanac data and ephemeris data we have. So almanac data means other satellites in the constellation, and we say that orbital data that is used for the message transmission. And each message is divided into 25 frames of 1500 bits, and each bit with a period of 30 seconds. Each frame we can say that is subdivided into a, that is about 1500 bits, each with a 30 seconds, and each frame is further subdivided into 5 frames. And that 5 frames of a 6 second duration of 300 bits, that is about 5 subframes of 300 bits here. And then subframes are divided into 10 words, and this 10 words of 30 bits with a 0.6 seconds of a duration. Then each subframe, if you see here, the first word consists of a TLM data, and the second word consider that handover word, and the remaining 10 bits, 10 words in each subframe carry the different information. In subframe 1, they carry the satellite clock and satellite health related information, and in subframe 2 and 3, they carry the ephemeris data. In subframe 4, they carry the partial almanac and other data, and in subframe 5, they carry the almanac data. That is about your satellite navigation message format.